exam. And it says the percentage by mass of calcium carbonate in eggshell was determined by adding excess hydrochloric acid to ensure that all of the calcium carbonate had reacted. The excess acid left was then titrated with aqueous sodium hydroxide. So we've got two reactions going on here. The first one is an acid with a carbonate, which we know is going to produce a gas. As a result of that gas, we're going to see bubbling, and we're assuming that it has all reacted when the bubbling has stopped. And then we take whatever is left over and figure out how much of that is left over by titrating, which we've done before with sodium hydroxide. One good thing in all of these problems is to go ahead and make sure you know what the symbols are for the different elements and compounds that are in any of these questions. So we can start out saying calcium is in the second column, so it's a 2+ charge. Carbonate is a polyatomic ion, it's CO3 with a 2- charge. So when we crisscross those, we have CaCO3. It's going to react with hydrochloric acid, which means we have hydrogen and chlorine bonded to one another. And both of those have 1 charges, 1 positive, 1 negative, so it's just HCl. And the sodium hydroxide, sodium is a 1+, hydroxide is a polyatomic group with a 1 negative, so it's just NaOH. Now that we have that underway, we can take a look at what the first part of the problem says. It says a student added 27.20 centimeters cubed of 0.200 moles per decimeters cubed of HCl to 0.188 grams of eggshell. Calculate the amount in moles of HCl added. We know that we can figure out moles of something, so moles of HCl in this case, by taking the volume multiplied by the molarity. So we look here, they added this much, which is our volume, centimeters cubed, and this 0.2 moles per decimeters cubed is our molarity, which means that this is extra information. One other very good thing if you're running well on time is to read through an entire problem. See here we've got A through G. That's a lot of different parts of a problem, and we're going to need this much later on, so it's just extra for now. Don't get confused when there's extra stuff at one point, and then when you get to another point, go back and figure out if they did give you that information, because sure enough, we're going to need that later. So we can just start looking at what numbers we have, but I see a problem right off the bat. We have centimeters cubed, but we have decimeters cubed in the molarity. Those are not equivalent. We need to figure out what will make them equivalent. And for every 0.001 decimeters cubed, we have 1 centimeter cubed. So I'm going to go ahead and say, okay, if I know my volume in centimeters cubed, and I convert it to decimeters cubed, I can multiply it by the molarity, and I've got my final answer for this section of it. So I would take 27.20 centimeters cubed, which 4 sig figs there, multiply that by 1 centimeter cubed on the bottom so that they cancel out, and on top is the other part of this equivalent statement, 0.001 decimeters cubed. So I've got the first bit of this out of the way. Now I can take my molarity, multiply it through. It is 0.200 moles for every 1 decimeters cubed. If I go through that entire thing, the significant figures of this don't matter. This one, it has 3 sig figs that we're going to want to take into account. We would have 0.00544. My 3 sig figs are that 544, and I know that because I can put it into scientific notation. 5.44 times 10 to the negative 3. And I don't want to forget what I'm talking about in these two numbers, so I'm going to put my unit, and I'm going to be very specific. I'm not only going to say mole, but I'm going to say that it's moles of hydrochloric acid, so I don't forget. So that's the very first part of this. The second part says that the excess acid requires 23.80 centimeters cubed of 0.1 mole per decimeters cubed of sodium hydroxide to be neutralized. And it wants to calculate the moles of acid that is in excess. So moles of HCl this time at equivalency is going to be equal to the amount of NaOH that was required to react this. So the moles of HCl would be equal to the moles of NaOH, which we know then would be equal to the volume of NaOH multiplied by the molarity of NaOH. And luckily for us in this one, we don't have any extraneous information, so we can just go ahead and look at our units, which again, they're trying to trip us up, centimeters cubed, decimeters cubed. I'm going to use that same conversion that I did before. So I'm going to take my 23.80 centimeters cubed, multiply that by 0.001 decimeters cubed for every 1 centimeter cubed. My centimeters cubed cancel out. Now I can multiply by my molarity of NaOH, 0.100 moles per decimeters cubed. Moles of decimeter cubed cancel out, or decimeters cubed cancel out, excuse me. Multiply all my numbers through. My largest number of significant figures is 3, so I'm going to make sure I use that for my final answer, and I get 0.00238, which again, the significant figures are just these 3 here, so we can put it into scientific notation. 2.38 times 10 to the negative 3, and that's moles of HCl again. Now it might seem funny, why do we have moles of HCl in 2 parts? Well, that's why we have this next question. We want to determine the amount in moles of HCl reacted with the calcium carbonate in the eggshell. So all we have to do is subtract these 2 numbers. This is the HCl that reacted only with NaOH. This is the amount of HCl that we started with. So we can take the 5.44 times 10 to the negative 3 and subtract from it the 2.38 times 10 to the negative 3 moles of HCl. Now this is easy for us. Even though it's in scientific notation, we don't need to worry so much about what power they're to. If they're to the same power, we're just going to be doing this normal subtraction. 5.44 minus 2.38. You shouldn't even need a calculator for it. It's 3.06 times 10 to the negative 3. We didn't use it in our calculation, but it's still there. We don't want to forget it. And you can just verify that if you want to. Do the normal standard number rather than the scientific number and put it into scientific notation later if you want. And that's moles of HCl. And that's the moles of HCl that actually reacted with the calcium carbonate. That's going to be important for us as we get to E and F